Okay, so today we're going to go over the Chapter 1 test review. We're going to look at it. If you have questions, please let me know. I can see the chat for those of you with me virtually. Those of you physically, you guys don't have to stop it. So, Chapter 1 test review. So I already see I have a few people I need to grade, which is awesome, and some in progress. Thank you guys for being on top of that. It is greatly appreciated. For the review, you will have up to 20 attempts. So if you don't like the score on the first one, you can take it again to see, oh, I tried to do some things differently. How'd I do? Remember, it will just be one attempt for the actual one. But if you run into issues with it, timing out or whatever, just let me know and we'll work on fixing that. Okay, so here with this, graph the following function and then find these values. So I'm going to work on graphing this. Remember with the piecewise functions, I saw a lot of you do a great job with this on the first quiz. You know, we're just going to put it into Desmos twice. Some of you hand graphed it. The hand graphs I saw were good. I know some students struggle with that with the piecewise. And if you're just like, I figured it out on Desmos, can that count? That counts. So I put in f of x is equal to 2x plus 1. And then I put my curly braces. And then my domain restriction said x is less than -2. X less than -2. There's some start of it. Then I can call g of x my next part of the function, -x minus 4. -x minus 4. And then again, I need that domain restriction on it. This one said x is greater than or equal to -2. Well, I did not hit a greater than symbol in there. Greater than, there we go. Greater than or equal to. There we go. And there's my graph. A lot of you did a very good job with this. There are 2 ways you can share it, or actually 3 ways. Some of you that were doing it on your phone, I saw you just took a screenshot with your phone, uploaded the screenshot. Great, that works. If you're on a non-mobile device, you could use copy and just copy and paste that link in for me and I'll see all your work. Or you could do export image and just download that image. Save file. I'm just going to do it the download image way. If you just want to send me the link, you can send me the link. It really doesn't matter at the end of the day, just as long as I have a way to see it. Okay, so that downloaded. Open that folder. No, I wanted to open the folder, not the file. There we go. So I can upload that file. I know that is under my downloads. Desmos graph. And upload. So now I see that, and that's a perfectly acceptable way to do this. Now I need to do f of -4, f of -2, and f of 3. So f of, where am I? -4. Well, come on, show them what I'm trying to type here. Did I not type below the picture? Oh, there we go. F of -4. So -4 is less than -2, so I'm just going to plug into the top one here. So f of -4, all I did was 2 times -4 plus 1. 2 times -4 is -8 plus 1 equals -7. -7. Okay, f of -2. -2 is at less than -2, but it is greater than or equal to -2. So I need to plug that in to the bottom equation. And again, if you want to just take the time to write this out on paper and upload that picture, just like we did the other one. Yes, it is recording and will be on Schoology, hopefully by the end of second block. So let's go back to where we were. There we go. That's equal to -2 minus 4. 2 negatives make a positive, so 2 minus 4 equals -2. Then I have f of 3. Well, 3 is bigger than -2, so f of 3 will be, let's plug in 3 to the bottom equation, -3 minus 4 equals -7. So that's the first problem done. Let's move on to the next, which here with this. Given the original function, we see that with the dashed lines here. And the new function, write the function for the transformations we see. So I see this went left 1, 2, 3, 4, and up 1. Our default equation here is a quadratic. So if you just feel more comfortable writing it out and uploading the picture, you can. But we can use the little t squared here or the math text to write this out. So I can say f of x. Now this doesn't flip or stretch, so I don't need to do anything in front. That's just going to be equal to. Now if I'm going left 4 units, that's going to be an x plus 4. Close parentheses. And I can use this little superscript here to put a squared up there, or you could just hit caret 2. I will read that as a square. And then it went up 1, so plus 1. So f of x is equal to x, or x plus 4 quantity squared plus 1. You're going, you know what? I want to check that on Desmos. So my original function was x squared. We see that I can type in what I typed, x plus 4 squared plus 1. Whoop. That needs to be a new line. Cut, paste. So if I look at these graphs, hey, that looks like this scenario here. Just the colors and shapes or the colors and the like solid versus dash is a little different, but it works out the same there. So that was a good way to check our work. Next question. Okay, this one is the same thing. We flipped it upside down, so there should be a negative in front. And then I went right 3, so that's going to be an x minus 3 in the parentheses, and down 2, so that's going to be minus 2 on the end. So I can just cite that in. F of x is equal to, that be negative x minus 3 squared. So I could put it with the little caret, but I'm going to actually use a little superscript here to make it look just a little neater. Minus 2. Let's confirm that on Desmos. Negative, okay. So I could do, again, I'm comparing it to this green graph here. Negative x minus 3 close parentheses squared minus 2. Hey, this black looks pretty similar to the green equation we had in this problem. So we're good. Any questions so far? Cool. I'm not seeing any pop up on the chat. I know you guys are pretty good with the chat as well. But if you do have questions, even you go back, just let me know. Okay, so for this, I'm defining what f of x is, g of x, h of x, and k of x. So you've got 4 different equations. Make sure you read the letters closely to choose the right one. So h of 2, I'm just plugging 2 into this h equation. H of 2, that's H of 2, there we go, is going to be equal to negative, then in parentheses 2 squared. I'm going to keep you, negative 2, then in parentheses 2 squared. And then that's plus 5. So let's see, 2 squared is 4, so I can have negative 2 times 4 plus 5. Negative 2 times 4 is negative 8. So it could be negative 8 plus 5. And that's equal to negative 3. Now, I kind of typed out my work as I was doing it there. You do not necessarily have to do that. I was just doing that so you guys can see where all that was coming from. Sorry, I know I just have like a few students that had recently popped in. I want to make sure your attendance is accurate. This way I don't forget, so I'll just leave that up for a second. Actually, I'll go to the next problem while I'm fixing that so you can guys see what it is. So this one, I'm going to need to plug F into K. So while I fix a few people's attendance, please take a look at that and see if you can maybe figure that out some. So them come in. They came in. I think that's it. Okay, awesome. So K of f of x. So what I want to do here is I'm going to take, say K of f of x. So I'm going to take f and plug that in to x here. So what I'm going to do, and if you want, you could actually use this math line, and that will give you some special characters dealing with math. You don't have to. It's just an option there for you. So I could be like, okay, K of f of x is equal to, let's see, K starts negative 3. Then I have an x here, so I'm going to put a parentheses. I can put 2x minus 1. And then after the x, it says minus 3, so minus 3. Let's distribute the negative 3. So that's going to give me negative 6x. Negative 3 times 1 is going to be a plus 3. And then it has minus 3. Well, minus 3 and plus 3, those just cancel out, giving me negative x, or negative 6x. And that's it for composing that function. Okay, so we got some varieties of these. Let's see, this one we just want to do f minus k. So to do f minus k of x, I'm just going to take away k from f. The only thing you have to be cautious with here is your sides. That's where probably 90% of our mistakes are going to come from here. So f minus k of x is equal to, that's going to be 2x minus 1. Then minus, I'm going to put it in parentheses, negative 3x minus 3. Close parentheses. I say, oh, I had this negative in front. Let's distribute that. That will give me 2x, or no, 2x minus 1. Then minus a negative 3x, that becomes plus 3x. Minus a negative 3 again becomes plus 3. Okay, combine our x's. 2 plus 3 is 5. Combine our constants. Negative 1 plus 3 is 2. 5x plus 2. So it's all just combining like terms there. So that's me showing all my work. If, again, you're just quickly writing this out on scrap paper, if you just give me that final answer, if it's right, it's right. If it's wrong, it's wrong. You take the time to show work, then, what was I about to say? You take the time to show work. If you just made a little mistake in there, I can give you partial credit. Okay. Here, I'm composing h into k. So it says k of h of x. I'm going to take this and plug it in again where x is. So k is my outer function, h is my inner function. So that's going to be negative 3. Then I see my x. The x gets replaced with this whole thing. Negative 2x squared plus 5. Close parentheses, that says minus 3, so minus 3. Start with distributing the negative 3. Negative 3 times a negative 2 will give me a positive 6x squared. And then negative 3 times 5 will be minus 15 minus 3. See, nothing combines with the x squared, so we don't have to stress that. Just 15 minus, or negative 15, sorry. Negative 15 minus 3 will give me negative 18. So 6x squared minus 18. Next. Oh, this one's looks crazy. Oh, you have a fraction here. What are we doing? Just literally write the two equations over top of each other. That's all that is. I know it might look a little crazy, but I'm just going to put f in the numerator, g in the denominator, call it a day. That's all we have to do there. So, let's see, with the math, can I make a big fraction bar? No, I can't. So what I'm going to do, so I'm going to, in parentheses, put f up top, 2x minus 1, then hit a division bar, and then in parentheses, put g in the bottom. X squared, nope, not x to the x, x squared, plus x. So all I did was write that as one big fraction. If you want to, again, take the time to handwrite that and just upload the picture, go ahead. Okay, g of k of x. This is going to be our most complex one. I'm actually going to take the time to write this on a Smart Notebook file, just because it's going to be cleaner that way with doing the square and all that. So g goes on the outside. So actually k is getting put in for this x and this x. So it goes into two different places. So let me get that smart notebook file up. Oh, last one repeated. Yes, yes, going back to the last one very quickly. So the last one, because it says F over G, get your equation F. That goes in your numerator. Your equation G goes in the denominator. So I just put them each in parentheses and then put a division bar between them to represent that fraction. So it might seem a little crazy, oh, I had to divide these. Look, we'll get into how to divide some polynomials later, but that's a later topic, not a right now topic. So we're just going to leave it at that. We could try and divide this if we really, really wanted, but it wouldn't be very interesting doing that. The ones where we'll have to do. Oh, if you wanted, you could just start it with writing like parentheses F divided by G, like that, of X equals, I just left that out this time. So we could have added that in front. I left it out. I'd mark it correct either way. Let's go to number 9 again and compose these. Okay, so this had g of x equals x squared plus x. K of x is equal to negative 3x minus 3. So since it says g of f of x, wherever I see x, I'm going to be taking this and plugging in. So that actually happens in 2 spots here. So that's going to be in parentheses, I get 3x minus 3 squared plus and a negative 3x minus 3. Plugging that in for the other x. Here's the biggest area you guys are going to have trouble with because I'm squaring this. Essentially, what I have to do is write it twice. 3x or negative 3x minus 3 times negative 3x minus 3. And then this can just be minus 3x minus another 3. We're going to have to use FOIL on this. So that's going to give me a 9x squared. Then that's going to be plus 9x. This here is going to be plus another 9x. And that's going to be plus 9. So all I did was the FOIL process on this. So I know that's something you've covered since, I should have hopefully seen that in IM1, but I know you at least saw that in IM2 and IM3. If you prefer the box method for multiplying something like this out, you can use that as well. I just find FOIL takes up less space, so I prefer that. And then that hangs out on the end. So here with this, something to combine with the 9x squared, so that's just 9x squared. 9x plus 9x is 18, minus 3 will be plus 15x. And then 9 minus 3 will be a positive 6. So that's my answer. Again, if I did all this work in reality, I'd take a picture of this and upload all this. For time's sake of doing that, what I'm going to do is I'm going to be confident in my work and just type in my answer. If that's how you're doing it, if your answer is correct, I'll give you the credit. But if you made a mistake in here and you're not showing your work, I can't figure out how to give you partial credit on it. So that's the advantage of you uploading your work to me, is if you had just messed up this FOIL process here and I accidentally wrote this as like a 12x, I could go, oh, you said 3 times 3 is 12. That was a silly mistake. I see where the mistake went. Your logic's good outside of that. I could give you most of the credit. So again, that was 9x squared plus 15x plus 6. So that's going to be your most complicated one with these combining functions problems. I will make sure to upload that work along with the video. Find the inverse of this. So here, again, I'm just going to do the work on scrap paper. If I were you, I would upload that work with it. Just because I'm doing it on my Smart Notebook file, and for time's sake, I'm not going to upload the full picture. I'm just going to put the final answer. So find the inverse of this. 2x minus 1. Okay. I will add numbers to this too, so we realize which ones they go with. So I am told that f of x is equal to 2x minus 1. So first step, we write y equals 2x minus 1. Flip your x and y. So wherever you see the letter y, replace that with the letter x. Wherever you see the letter x, replace it with the letter y. X equals 2y minus 1. Now my goal here is to just solve for y. Add 1 to both sides. X plus 1 is equal to 2y. Divide by 2. And we get y is equal to x plus 1 all over 2. Now me, personally, I'm a fan of the big fraction like this. However, I saw some of you on your exit tickets on this stuff said you don't like the big fraction, but realize you can split it up. If you prefer, you could write it y equals x over 2 plus 1 over 2. I saw many of you on exit tickets involving inverse functions write it like this as opposed to this. They are equivalent. I don't care which way you write it. My personal preference is to one big fraction as opposed to the fraction split up, but that's my preference. Both are mathematically equivalent statements, so I don't care which one you give me. So here, the final step, remember I said we can write it as like f inverse of x is equal to that or the other one. So again, that would be me showing all my work. If I were you, I make sure to upload a picture of all this work. This way, if you made a small mistake in it, I can figure out what it is and give you partial credit. I'm just going to get the final answer as I know that I got this right. So let's see. So that was F. And some of you left it as Y. If you put it as Y, I'm not taking all points there. But I'm putting it as F inverse, so it's obvious that that is the inverse of this. But if you leave it as Y equals, I'm not going to be that nitpicky on it. And then I had in the numerator, x plus 1, all divided by, not minus 2, divided by 2. That's it. We got one more question. It's another inverse question, and we're done. So this inverse has an x squared in it. 2x squared plus 5 So it's going to add one set to the end that's not actually too big of a deal. That extra step added is not too hard, because if you think about it, the opposite of squaring something is taking the square root. So just as long as you take the square root in the end, you're fine. You'll follow an incredibly similar process. So let's pull up that Smart Notebook file and get this last one done. Very similar process. We start f of x is equal to 2x squared plus 5. Rewrite it as a y equals 2x squared plus 5. Switch x and y, so the y now becomes x, and then the 2x squared now becomes a 2y squared plus 5. Now it's all a matter of solving for y now. Start with subtracting 5. This gives me x minus 5 is equal to 2y squared. This is going to be a good example of why I like to write it as a big fraction as opposed to splitting it up, just because I feel it looks a little neater. I'm going to divide by 2. And that gives me y squared is equal to x minus 5 over 2. Now, to get rid of the squared, I can take the square root of both sides. And when I do that, that leaves me with y equals the square root of all of this. I could also write that if I wanted, f inverse of x is equal to the square root of all of this. So I'm just going to type this in. Guess I feel this just looks a little neater. Just one big fraction underneath my entire square root, as opposed to two smaller fractions. Again, you want to split that up as a square root. The square root would have to go over the whole thing, but that'd be x divided by 2 minus 5 divided by 2. That would be acceptable as well. So again, I'm just typing in my answer. If I were you, I'd upload all the work you did. And again, these will be saved and numbered later today and uploaded to you. So here, f inverse of x is equal to, then I'm going to need to use this for the square root symbol. And then I'm just going to put the entire thing in parentheses behind it, x minus 5, close those parentheses, divided by 2, close that other parentheses to say it's all under the square root. And we're done. So that is what I have for you. I'm going to stop recording.